Here we go. We have a question: detect loop in linked list. So you are given the head of a single linked list. You are tasked to determine whether the linked list contains a loop. A loop exists in a linked list if the next pointer of the last node points to any node in the list rather than being null. So we have given this linked list, and this is, and we have also a position. So position is not provided in the argument function. Then we need to find out whether the linked list contains a loop or not. In this, it is clearly visible that the last node points to the second node. So that's why the answer is true. It contains a loop. In this, we have a linked list, and it did not contain a loop. So we need to detect whether a linked list contains a loop or not. So I have taken one loop example and one single example. So the naive approach will be to first add this node into the map, add this node into the map, this node, map or set you can prefer. Then add this node, this node, this node, then this node. Then you will jump into this node. This node is already present into our set, so we will return true. Means this node, the linked list contains a cycle. But there is one better approach. The approach name is slow and fast pointer, or another name is hare and tortoise algorithm. Slow and fast. Initially pointing to the head node, then slow will jump one step, fast will jump two step. Is it equal? No. Then slow will jump one step, then fast will jump two steps. Again, is it equal? No. Slow will jump one step, fast will jump two step. Is it equal? No. Slow will jump one step, fast will jump two step. 1, then 2. Is it equal? No. Slow will jump one step, fast will jump two step. 1, 2. Is it equal? No. Slow will jump one step, fast will jump two steps. 1, 2. Is it equal? Yes. So it contains a loop. Now let's find out for the single linked list. We have this slow and fast pointer points to the head node. Then first slow will jump one step, fast will jump two step. Is it equal? No. Slow will jump one step, fast will jump two steps. Is it equal? No. Slow will jump one step, fast will jump two steps. Is it equal? No. But your fast is null. We cannot move ahead. So if your fast is null, or if your fast next is null, we will stop. Why fast dot next? Because let me write another example of odd nodes, odd number of nodes. 4, then 5. So we have a slow node, we have a fast node. Is it so first we have to make a jump. Is slow will jump one step, fast will jump two step. Is it equal? No. Slow will jump one step, fast will jump two step. Is it equal? No. We can jump, slow can jump one step, but fast cannot jump two step because fast next is null. So if your fast next is null or your fast is null, it means we does not have a cycle. The answer is false. We don't have a cycle. Let's implement this. We have slow pointer, fast pointer. While this condition holds, fast will jump two step, slow will jump one step. If it is equal, return true, else false. As simple as that. Let's submit this. I hope it will work. Now let's talk about time and space complexity. In this code, the time complexity is order of n by 2, you can say, but it is equivalent to order of n, and space complexity is constant. Now let's find out. We have met the expected time and space complexity, and we have successfully solved this question. I hope you have learned something new. Give this video a thumbs up, subscribe to this channel. I will provide this code in the description box. If you still have any doubt, feel free to ask in the comment section. And thank you all for watching this video.